This is the Tomcat talk. It's a talk we have been doing for the last couple of years together. I'll let Dan introduce himself.
Hello everyone. I am Dan Mikusa, and I work for Pivotal. I'm on the support team, and I've been supporting Tomcat and TC Server there for roughly the last 5 to 6 years. And then I've been working with Tomcat for probably another 3 or 4 years on top of that. I also work with the Spring Cloud Foundry products there, so everything kind of ties together. If you're ever on the Tomcat mailing list, you may have seen me reply to some posts there. I tend to try to keep active on that list, and also on the Tomcat expert blog.
I'm Stuart Willliams. I am a long-time user of Tomcat as well. I've been using it since around 2000, and I'm less active on the Tomcat mailing list now than I used to be, but I'm still an open source committer on a number of projects, Apache and Eclipse. And I also work at Pivotal. I've been with the Pivotal organization and VMware before that for 4 years. And I'm currently the project lead of a commercial product called RTI. I'm doing a talk about that tomorrow. So this talk is not a talk about Tomcat being the fastest servlet container. It's a pretty null-sum game to try and chase off the differences between application containers, because as you'll see, we'll explain during the talk that most of the performance in the application comes from your application. So this is a talk about how to make your servlets and applications perform well under load, and some of the things that we've learned over the years that we've been using Tomcat. And in fact, we think it's easier than you may think if you follow some fairly simple rules. So a little about Tomcat first. Tomcat was the reference implementation for the servlet spec. It was donated by Sun to the ASF in '99 and became a top-level project in 2005. It was part of the Jakarta Commons Java projects before that. We're now up to version 8 of Tomcat, which supports the latest version of the servlet specification. Each major version of Tomcat supports a servlet specification release, and there are minor releases of Tomcat in between to do bug fixes and modify small features. One of the most notable additions to the container is WebSockets. In 7 and 8, 7 was a proprietary implementation in Tomcat, and 8 is the version that supports the servlet specs WebSockets API. And Tomcat, as you may know, is being increasingly adopted as the trend towards lightweight application servers has increased in popularity. So before we go any further, we have some questions for you. So if you could put your hand up if you've brought a Tomcat app to production, ever? Okay. Who maintains a Tomcat in production today? So most of the same people, but a few less. So it was I'd say about 2/3 of the room, and maybe just under half. And what do you know about the average load on that production server? Do you know your daily active users? Can you put your hand up if you do? In fact, everybody who's got their production Tomcat in now, put your hand back up. And now take it down if you don't know your average load. So there's only a few people with their hands up who know their average load. So I'm guessing that of those people, you may know your daily active users, your daily active sessions, and your requests per day, per hour, and per second. Yeah, good man. Why are you here? Yeah, okay. So we said we give a prize for the provably largest, so come and find your beer credits later. So before we go any further, we thought it'd be useful to explain what the Tomcat internals look like and give you some context for what we're talking about when we start tuning a Tomcat application. So there is quite a lot of text on this slide. We couldn't figure out a way to make it smaller, but go with us for this. So we've drawn a hierarchical concentric diagram which shows the major components in Tomcat. You see the outer grey box is the servlet container itself, and at the top level we have the server component, and the server component can have multiple services. In practice, you usually only have one service. Each service has a combination of a single engine and a number of connectors, And then inside the engine, you can see that there is the realms for security, the cluster if you have a cluster enabled, and something that we put to one side, which is valves. In fact, the valves is a component that should really perhaps wrap all of a host container as well, because everything from the valves on downwards is part of a processing pipeline. Inside, you can have separate valves, you can add your own, you can add configuration that modifies each request behavior. But inside the valve container is the hosts, the context, which is the name for the application that runs inside each host. And inside each context, there is a loader, which is associated with resource and class loading, the manager, which is responsible for session management, and the resources, which may include things like database connection pools and so on. And of course, last is servlets. And inside the servlets, you sometimes have something like the Spring framework, which takes control of the rest of the application for that framework, or maybe you're building or implementing your own servlets. So in red, we've marked the components which don't hierarchically influence the rest of the containers inside. So you can see that the realms, cluster, and valves can all be, and resources can all be placed at different levels in the rest of those components. That's what we wanted to highlight there. So another word on the execution path. So when we see this diagram here, you can see the connectors are in the top or outer layer, but it doesn't mean that we execute through every single outer layer. We don't have a concept of having to execute through the server or the services, for example. The outside world's first place to touch Tomcat is the connectors. So the connectors are tunable. So this is our first place where we consider something that can be tuned or modified for performance. The engine is not tunable. The valve pipeline, the host, the context, and the servlets themselves individually don't have any features that you can use to tune. But your application is also tunable. So you can see really only the either end of the pipeline are opportunities to modify the behavior of the application in terms of performance. So we're going to have three main areas to focus on when we talk about what you can tune in Tomcat. The first one's the obvious one, and the one that almost everybody, when they're learning about Tomcat and they've deployed their application, they try to tune memory and operating system behavior first. So JVM, memory options, and GC config. Open file handles, people are not always aware that this is a key factor to tune in your application server. A U-limit on Unix systems has a number of different features which may impact the behavior of your application, and TCP settings, including socket buffer sizes. Some of these are available inside the containers configuration. And we'll talk a little bit in a moment about memory configuration. And after that, we'll look at Tomcat connectors, the type of connector you select, and there are quite a number of connectors that are available in Tomcat, makes a big difference to how your application will behave under load. And your choices for how your application should work will be influenced by, it can influence the connector choice that you'll make. And last of all, we're going to talk about your application and things that we know that you may miss or you may not fully understand about how to tune your application's behavior. So memory. So there is an awful lot to talk about when we think about the JVM's memory behavior and performance tuning. And this isn't a JVM tuning talk, but we are going to go over the high-level view of the JVM and the things that will influence the behavior of your application. So put your hand up if you've ever seen a diagram of what the heap, the process heap, the object heap looks like before. So that's about a quarter, a third of the room. So for those of you who haven't seen this before, and for those of you who have, a refresher, the process heap is the JVM itself. The process heap is what the operating system sees. Most people, when they're tuning the heap, don't immediately understand that what they're really tuning for memory size is the object heap. And you can see on the right-hand half of our diagram, we have the non-heap area, and that includes in Java 6 and 7 before, the permanent generation, which is the class space used for class loading. In Java 8, this has been replaced by the meta space. But also in the non-heap area, there are the thread stack memory, native code that the JVM uses, compiler code, the code cache used by the JIT, and other smaller areas of memory use. The object heap itself is broken down into a number of generations. The young generation is where new objects are produced. And that further breaks down into Eden. That's the very first place objects are produced. And objects, after they survive a number of generational checks by the garbage collector, will move to one or other of the survivor spaces. And surviving that, they'll move to the old generation. Normally what you see in applications is the default configuration for something like a web application, because you're producing so many new objects for each request, you don't have enough space available in the young generation in your application. So almost always one of the first things that we look at for tuning in the memory allocation of space allocation for the JVM is increasing the young generation space, so it's and using an appropriate amount of space so that you're not producing objects that unnecessarily move to the old generation where garbage collection cycles are much more expensive. So some more questions. Who has seen an out-of-memory exception in production? Hands up. Come on, there's got to be more hands than that. Would you keep your hands up, please? You can put your hand down if it was not an unfortunate configuration. We'll say politely, an unfortunate configuration choice. Not many. Coming down there. Just not enough memory. You can take your hand down if there just wasn't enough memory. And then you have to put your hand back up if all you did by adding more memory was just delay the inevitable OOM. Yeah. So was it a leak in your application? A real leak in your application? Okay, good. A leak in Tomcat? See?
What I'd expect.
That's the right answer. Okay, so on memory tuning, some basic rules. Start with the defaults. A modern JVM is pretty clever. There's a lot of engineering gone into the behavior of the garbage collector and memory allocation in the JVM. They will get you surprisingly far. In most cases, you don't need to do a great deal at all. Don't guess about the settings. Read the manual. Know what they do. Make a good decision. You just waste cycles, waste your time. And if you go through a long process to get your application into production, we know that lots of people have painful processes for deployment, multiple staging areas, and so forth. It can be very frustrating to find that when you get to the other side, the thing really doesn't work at all. And when you're testing, and we'll go into some more detail about testing shortly, change one setting at a time. Even if running a test cycle means spending several hours or even a day doing something, really try to understand what you're doing and what the impact of one change is, because it's all too easy to make a change in one area that's beneficial and a change in another area at the same time, which is completely counterproductive. As helpers on the Tomcat mailing list, we see fairly frequently people saying, well, I read on Stack Overflow. I read in a blog or a forum post that I should use this setting. All right. Understand what that setting is. It may not work for you. You have to understand, you have to learn from what the description was, take that knowledge away and apply it appropriately. You can't just assume that there is a magic switch that says don't suck and it will work. You must monitor your application's memory usage when you're tuning Java and garbage collection. Use JMX. JMX API in application, Java application is very, very detailed. It tells you an awful lot of information. And you can also output a GC log to file so that you can record and monitor this and reanalyze it at a later date. Test your app, observe the results, adjust memory settings, and repeat until you've got a stable configuration. A couple of things to note. Tomcat doesn't use very much memory. If you start a typical Java application up, you'll see even just with an empty application server, Tomcat, it will use very little memory until you start doing something to it. Tomcat does have a look at background processes which will tick over time, and you'll see that if you use JMX to look at a standard Tomcat when it starts up, it'll probably kick up to using 32, maybe 48 megabytes of RAM, and then it'll settle back down again to around 20 with no applications deployed to it. So that's a very small amount of memory to be using. When you start to see requests coming in, Tomcat does have some strategies for making sure that it doesn't increase object allocation unnecessary. For example, the request handling objects that the connector uses are pooled and reused. So we don't see a lot of spurious object production in Tomcat. Keep track of how many connections you have into the server. Connections are not the same as requests per second. They're not the same as user sessions. Connections are literally the network connection in. You may see those happening much more frequently for different types of load, and it's not always immediately obvious how this behavior is. And the type of connector you're using will influence this immensely. Each socket for each connection uses memory, and while you can change the socket buffer sizes, it's very rare that we find that it's necessary to do that. I've never had to do that in a production Tomcat server. Oversizing a memory buffer can have extremely unpleasant effects to garbage collection. It makes the JVM quite unstable. So the most common memory switches, who doesn't recognize any of the ones on this slide? If you put your hand up, maybe put your hand up if you do recognize it, it's probably easy. Yeah, some hands, okay. So the MX is probably the most well-known one. Set the maximum object heap size. MS is the initial heap size. We usually recommend in an application server like Tomcat, set them both to the same. There's not usually a good reason for allowing the JVM to resize itself over time on most workloads. You want to make sure you've got all the memory available that you need to run the application when you start the application up. The last one I referred earlier to making sure that we have enough memory in the young generation in the first area of the JVM's memory space. And these are configured using either XMN or XX new size. That's the fixed size way of specifying how much of the available object heap is assigned to the young generation. But I tend to prefer using the new ratio. So it's more explicit to say that the new ratio is by default a ratio of 1 to 7, which means that you have 1/8 of the JVM assigned by default to the young generation of the JVM. So when you're setting the new ratio, if you find that you need more memory, you either have to increase the overall size to increase the young generation, or change the ratio. And depending on how much memory you really need long-term persisted, which will end up in the old generation, will influence that decision. The other thing about the new ratio is it's an excellent reminder that you can't use more than 50% of the JVM's memory, or you shouldn't use more than 50% of the JVM's memory for the young generation. And the way to do that by setting new ratio is to set it equal to 1. So you can't set a smaller number than 1. So the other settings, permanent size in Java 6 and 7, max perm size and perm size, and the equivalents for the meta space in Java 8. And lastly, the thread stack size. The thread stack size is kind of an interesting setting. It's another one you very rarely need to set. But occasionally, if you've got an application like a content management system or something that's using a number of frameworks, then you may find that you need to increase the stack size under certain conditions because of the amount of memory that's being used in an individual thread's memory space. So if you have a very long stack trace, that's normally a signifier you need to look at this. And there's a very specific OOM that you'll see with a different message if you're running out of stack space. So at this point, I'm going to hand over to Dan to talk about our Tomcat connectors.
Okay, so as Stuart mentioned earlier, there's a number of connectors that Tomcat gives you out of the box, and each one of them kind of has, their own different things that, strong points and weaknesses. So I'm going to kind of run through the different connectors that you get and kind of give you some idea when you might use one of them. So if you're using an older version of Tomcat, like 6 or 7, you're going to be with the BIO or the blocking IO connector as the default. And it's the default because it's been around the longest and it's considered to be the most battle tested and stable of them. It is a blocking connector, so one thread is going to be used to handle one connection. Sometimes that is a good thing. It can actually, when you have small number of connections, it can actually result in a slightly lower latency on the request. But once you start to have a lot of things going on at the same time and you get the concurrency up, that kind of flip-flops and you start to see kind of a drag on performance, and then you have to start increasing the total number of threads, and it kind of gets messy. The NIO connector, which is based on the NIO framework in the JVM, is now the default in Tomcat 8. and it's a non-blocking connector. Personally, I think it's incredibly stable, and if you're running a later version of Tomcat 7, it's also a good candidate there as well. So it's not just something that you could use in Tomcat 8. It is like I said, with the blocking I/O connector, it may not perform quite as well with very small number of requests, but once you start to get a lot of concurrent things going on, it's going to really outperform the VIO connector. Another one that's brand new in Tomcat 8, and it's very experimental at the moment, is the NIO2 connector, which is based on the framework of the same name in the JVM. It's not something I'd use at this point unless you just want to play with it and see what happens, but it is there, so it's worth noting. The other one that's been around for quite a while is the APR connector, and this actually uses some native code to kind of accelerate things. It's also non-blocking, like the NIO connector, and it typically has the best performance of all the connectors. Just the downside of it is that you have to compile a native module, and you're using some JNI to integrate that into Tomcat. So that's kind of the trade-off. In some systems where you need every last bit of performance, it's worth doing that. In other systems, you might not need that, so it's just not worth the time to compile that and get it configured. The last thing to mention is that each of these 4 types of connectors are available for HTTP requests and then also for AJP requests. So AJP is just a different protocol that Tomcat speaks, and it's really only used if you've got an Apache web server in front of your Tomcat server. And then instead of talking over HTTP, you can configure it to use AJP to talk to your backend processes. But they have all the same variants, BIO, NIO, NIO2, and APR. Just as I mentioned before, these are just the version numbers where these connectors became available. So you can see that BIO is back around from the original version of Tomcat, and the NIOs were added as we went along there. This is kind of just what I was mentioning before, but just a summary. BIO is good for low concurrency, and when you have a very small number of keep alive connections or none at all. If you start doing a lot of keep alive, that's when you're going to have better time with the NIO connector or the APR connector. If you're doing SSL with your Tomcat instance, you're probably going to want to look at the APR. I have some stuff I'll show later about that, but you're definitely going to get the best performance with APR. The NIO connector does fairly well with SSL, but what it boils down to is it's just that the NIO connector is using the JVM's SSL implementation, which itself is just not as fast as OpenSSL. So we did some basic testing, and I'm going to kind of talk about what we did and go through some of the stuff. We'll get to the numbers at the end, which I'm sure is what everybody wants to see. But kind of before we get that, we want to cover some of the foundations for testing. So as Stuart mentioned earlier, you want to make your performance tests worthwhile. So to do that, you need to make sure that everything is stable and that you've nailed as many bugs as possible prior to doing that, so you're not wasting your time doing performance tests. So the very first thing you want to do is you make sure you have good unit test coverage. Make sure everything works. Then you want to have some integration tests, just so that you can make sure that when you're running Tomcat, everything is good. Tomcat can be embedded, so that's an excellent use case for some integration tests. And with Tomcat 7 and 8, it's pretty easy to embed now. Once you have a fairly stable product, that's when you start looking at doing some system or performance tests. The key to this is that you want to make sure you try to match your performance environment with your production environment. If you do a performance test on a system that has half the CPU and half the RAM, it doesn't really mean anything because you don't necessarily know it's going to scale linearly when you go to your production system. So you want to try to get the two as close to the same as possible. Your application needs resources. one old server that's sitting in your closet isn't going to cut it. You need to make sure, again, that you have a good, solid server to run on that's going to be, similar to what you're using in production. The next thing that you need is a good load generator. It takes a fairly significant amount of resources, to generate load as well. So you need some, strong servers there for that. In the test that I'm going to talk about in a minute, I actually went with, two load generators to one server, because it just the capabilities that were necessary to generate the load onto Tomcat needed to be that high. So that may even be a possibility too, where you're going to need to have more load generators than actual servers. Of course, because we're open source guys, we favor the open source tools, and that's kind of what we'll talk about here. So there's a general process for performance testing, and if you vary a whole lot from this, you may end up skewing your results. So just talk about this briefly. The first thing you're going to start with is a working system. You're going to make sure that you understand what you're trying to test here. You have to have some goal. How fast is fast? What does management want to see in terms of response time? How many requests per second do you have to fit on the servers that you have? Things like that. The next thing you need to be able to do is measure your current performance. And as Stuart mentioned, JMX is a great way to do that. You can get lots of metrics from that. You can log those. You can use a metric monitoring platform, whatever you like. But you just have to be able to understand and put a number on your performance. Once you've had a chance to gather some metrics, you want to go through and kind of establish where the pain points are. What's causing a problem. What's preventing you from hitting those goals that you've set, because you want to make sure you focus on the correct spots in your application or in your configuration. After that, obviously, you got to figure out what's going to fix it. And then you're going to have to just keep repeating that until you get to the point where you've met your goals. Again, you just want to be realistic with your goals. Unless someone from Twitter or Facebook's here, you may not have the same goals as them, so you may not need to scale to quite that level. So as you're talking about it with your team, with your management, make sure they're realistic on what the needs are for your application. Some things to think about, you want to make sure you account for your annual peaks, account for some failure, and then also realize that the more resources you put into something, the more that's going to end up costing. And so, there is some benefit to doing this tuning as well, because you can reduce the number of servers and you can end up saving your company some money, which is good. As far as test goals, you can test the performance of the basic Tomcat features. Those are things like serving up static files, small JSPs, things like that. That'll get you an idea for how Tomcat itself is performing. As we mentioned before, the majority of the work's in your application, though, so where you're going to get some really interesting situations is when you start to test the different flows through your application. Of course, you want to iterate, make small changes, see how those things impact the performance, and then make sure that you're throwing consistent amounts of load at the server, because you don't necessarily want to vary. Varying the load is another one of those things that you can change. And so if you vary the load and you change settings and you do other things, and you get to the point where you don't really know what made the problem go away or what made the problem worse. So we went and did some basic tests, and we set those up. They were running on a VPS system that we had. Just a Tomcat, the latest 8.0 release with OpenJDK 7. Just some basic facts here about the system that we had configured. We had all the details we included in the GitHub repo that we'll show at the end here. Or actually, I'll show right here. I'll leave this up in case anyone wants to write it down. All right, so we ran through a series of 7 tests, and these are basically just testing the components of Tomcat. So we started out with a small file, it was 32 kilobytes. We served that up with the NIO connector. Then we went on to telling the client to use Keep Alive. And we wanted to see how if a client was using Keep Alive, that would affect our server. Then we said, let's try a slightly larger file, see what happens. And let's try a really large file and see what happens. From there, we went to testing SSL, the APR connector, and then the APR connector with SSL. And so you can see how what we just talked about, we're progressing with very small changes as we iterate through our tests. And that way we can make comparisons between the different tests and kind of understand how those changes affected things. So on the left here, we have the different tests, and one of the metrics that we were looking at is the requests per second average. And the tool that we used to generate load was AB, which is just part of the Apache web server. And it's installed on a lot of systems. If you have a Mac, it's on your system right now. If you have a Linux box, it's easy to install. Windows, you can probably get it too. So basically for the different tests, we went through, we threw an equivalent amount of load at each test scenario. So we started with 2 different clients that were connecting to the server with 25 connections on each client. And you can see that the first column here is the list of one client, and then the second column is the second client. So if you sum them together, that would be the total load on the server. So some of the interesting conclusions that we can draw from this, when we tell the client to use Keep Alive, we see that the requests per second go up about 300 per connector, about 250 per connector. We can see that as we increase the size of the file, the request per second goes down. And that, that makes sense because bigger files take longer to download. We can see that when we add SSL, the requests drop significantly. If you look at the results from number 1 and number 5, both of these were serving the same file of the same configuration, except that 5 has SSL enabled, and that's with the NIO connector. So you can see that there's a pretty big hit there. We can also see that if we look at number 1 and number 6, that when we turned on the APR connector, we got a nice little boost in the number of connections as well. And we can see that looking at number 5 and number 7, that when we turned on the APR connector with SSL, we more than doubled the number of requests per second that we could get. So as I mentioned before, that's, if you're doing SSL with Tomcat, APR is a nice way to go. Because the number of requests per second isn't everything, there's other metrics that you can look at. One of the ones that AB will give you out of the box is different percentiles where your requests fall in. So it'll say, this is the longest request in this percentile. So in this case, we looked at the 99th percentile. We said, which basically says 99% of the requests came in shorter than this. And so we can kind of draw some similar conclusions to the last one. Like it takes longer to serve larger files. The latency goes up on that. And that SSL, impacts our latency as well. And again, that using APR lowers the latency for normal and with SSL. Performance talk wouldn't be anything without some fancy graphs. So we've got some graphs here to show you kind of a visual representation of serving up requests with the NIO connector, which is going to be on your left, and the APR connector, which is going to be on the right. And so what we're looking at here is kind of a histogram that buckets the requests into different groups. And so the first group here you can see is requests that are 0 to 10 milliseconds, then 10 to 20, 20 to 30, 30 to 40, etc. And so the larger the graphs are to the left, the better. So in this case, we can see that this is 40,000 plus requests were handled in the 10 to 20 millisecond range with the APR connector. We're slightly less than that with the NIO connector, but it's not a whole lot off. Again, if you're trying to get every last bit of performance, APR is nice, but you have to be realistic and it may just not be necessary. So this chart's a little, it showcases the difference a little bit more. You can see with SSL turned on, we're hitting 20,000 plus requests that are handled in these first two, less than 20 millisecond groups. With the NIO connector, it's dropped to around 12,000 or so. So there's a pretty significant difference there. And these charts, one of the nice things about AB is that there's a flag you can set and it will output the information to generate these charts to a file. So when you run it, you get this data file that's generated, and then you can use either a spreadsheet to generate your graphs, or I use GNU plot, which you can find some kind of recipes for online to generate graphs like this. And I did include the plot scripts that I use to generate these graphs in the GitHub repo. So if you're interested in seeing those, you can take a look at those. So, the question now is what else? There's all sorts of things that you could performance test. We could have compared things against the blocking I/O connector, to kind of back up some of the claims that we had talked about earlier. We could have adjusted the number of concurrent connections. We were really only throwing about 50 users at our server at any given time. So we could, double that and see what happens. We could start testing with some dynamic content, see how that affects things. We could start looking at CPU usage on the servers to see what happens there, and all sorts of different things. So this just kind of goes back to, what are you trying to test? What are you trying to prove? What are your goals? So the next thing we're going to talk about are profilers. And, a good performance talk would be, can't skip those. Because we've mentioned that applications are kind of the number one spot where you're going to be tuning. Profiler is going to be something that you're going to look at because it's going to show you where in your application time is being spent. The tricky thing with profilers is that when you run a profiler, you're going to change the performance of your app. It's doing things in the background, so it's going to slow your app down. And so you kind of have to consider that while you're doing it, and you absolutely don't want to do that when you're running in a production environment. There are a couple profilers that you may not know about that are free and that come with the JVM. The first one's Visual VM. How many people have used Visual VM? It's kind of the successor to JConsole. Good. And then since a later release of Java 7 and with Java 8, we now have what's called Mission Control. Has anybody played around with this yet? A couple people? Okay, we'll show that later. It's a pretty neat tool. And then you have your various commercial profilers. YourKit is a nice one. They're very friendly to the Apache products, so we like them. And then there's also a different suite of test tools or kind of profilers that can be used to target very specific things, library functionality and things like that. This is JMH is an example of one of those. So I'm going to try to show a quick profiler demo here, just to give you guys an idea of what you're going to see. So I've got a Tomcat instance running, and I'm going to start YourKit. Every profiler is a little bit different. But in YourKit, you kind of have this tab here where you can pick from a Java process that's running. Some profilers you have to install a little agent into the JVM that will produce this information or connect to your profiler. So the process varies a little bit. But once we select that application, it'll attach and just give us a whole ton of different information. And we can see our CPU information. We can browse through and see what's going on with individual threads. This is great if you're having, blocking issues or deadlocks. There's quite a bit of memory and garbage collection information that you can gather from here as well. And then there are all sorts of things that you can do to capture exceptions and, monitor certain extreme use cases that you might encounter. All of this information is available through your profiler. One of the things that's worth mentioning about this is that you can also save what's called a snapshot from your profiler. And the snapshots are really good because it's something that you can send to someone else who has the profiler, and they can take a look at it too. So it's a good way to communicate between teams and say, hey, we captured this unique scenario. Can the developers take a look at it? And then your developers can pull up that snapshot, drill through it, and find the information they need to correct the problem. So it's a good way to communicate between your teams. Okay, so as we mentioned before, applications. This is where 90% or higher of the time spent processing a request is going to be. It's in the code that you're writing and that you're deploying to Tomcat. So earlier, Stuart kind of alluded to there were some different things that you could tune, and he kind of had them listed in this reverse order to what's on this screen. And what we're here to tell you is that this is the actual order that you should be looking at when you're looking to tune things. You should be looking at your application first, possibly some connector tuning next, a little bit of tuning with logging, depending on how your server is set up, and then the very last thing is the JVM tuning. And it's just, we recommend this order because that's where you're going to get the biggest bang for your buck. The most performance gain you're going to get is from your application. You can adjust some of these other settings, and they'll give you some benefits, but there is no magic bullet that you can turn a flag and make your application go faster. So to try to illustrate that point, we have this screen. So this is the diagram that we had earlier of Tomcat, and that's your application, or a prospective application. And you can see that unless you have a trivially simple application, what you're trying to do, the logic you're encapsulating in your application, is far more complicated than what Tomcat's doing. And so, that's why you have to be realistic and look there first for what you can tune and what you can do to improve your performance. Your application's probably, filled with third-party libraries like, Commons HTTP client and, Commons DBCP and the Spring framework, hopefully, and all sorts of different, database and messaging and thread pools and things like that. Those things all, have their own individual tuning settings that you can adjust. They're going to help you get, better performance by looking at those first. So, going back to the profiler, you can get, a nice view of the time that's spent in your application by looking at the profiler. And if you can see this, it's just an example of what we were talking about before, where the majority of the time is not spent in Tomcat. This is a very simple Spring application that I pushed here. I threw a small amount of load at it with JMeter, and I watched it in the profiler. And what you can see on this line that's highlighted is that the first point where the Spring framework gets interjected here, we see that 99% of the time is spent below that line, which means that roughly 1% of the time was spent in Tomcat handling that request. And that's probably the most extreme example you're going to see, but it's just to illustrate the point that time is spent in your application. Understand what's going on there and tune accordingly.
That was quick.
Yeah, I feel like we missed a demo.
Let's look at the Visual VM and JCons.
That's right. All right, so we missed a demo in there, so I'm going to go back and show that. The tools that we talked about earlier that come with the JVM are quite nice, and I'm going to start and show you Visual VM. So this tool is included with the JVM, and it's based on NetBeans. So when you run this for the first time, the first thing you're going to want to do is go up to Tools and Plugins and install some plugins. It does show some good information out of the box, but there are some fantastic plugins that will help quite a bit. So these 5 here are ones that we heartily recommend. The first one is not actually available through this install window. You have to download it separately. And so on the left tab here, you have a listing of your local applications, and you can connect to remote applications as well. You can also grab thread dumps and heap dumps through this tool as well, but we're not really going to talk about that so much here. So if I connect to my Tomcat process, I can see a lot of similar information that I would see in JConsole, but then we have just tons and tons of additional information. The monitor tab is going to give us some basic information about the CPU usage, and down at the bottom we can see some high-level information about threads and the classes that have been loaded. The threads tab, as you would expect, shows you more about the threads. And then we have these sampler and profile tabs, which are basically visual VMs equivalent to what we saw in YourKit. So, if you don't have a YourKit license, you can't afford it, or your company doesn't want to pay for it for you, you can use Visual VM, and you can grab, a lot of the same information. This tab here is one of the plugins that we suggest you install, and it's just a basic MBeans browser. So this will let you see JMX information from the Tomcat server. If you've never looked at this before, just a quick introduction. This Catalina node here is the top level where pretty much everything from Tomcat's going to be located. So, we can see information here about the global request processor, which there's one listed for each of the connectors you have. And you can get information like how many bytes have been sent, how many have been received, the request count, things like that. Other useful things in here, you can see your thread pool, so you can see how many connections are running at the moment. How much room do you have, things like that. You can also drill down and get information about the applications you have deployed, about resources that you've created, such as data sources, and all kinds of other fun stuff. This garbage collection is, again, similar to what you'd get in YourKit, but it's just giving you some understanding of what's happening in your application, when it comes to garbage collection. Memory pools is a really nice plugin, and it gives you a really good breakdown of the different areas of memory. And Stuart kind of had that picture up earlier. And with this plugin, you can kind of see in a live JVM all those different settings. So we're looking at a Java 8 JVM here. So we do have metaspace. We also have these other various spaces. Here's our Eden and Survivor spaces. Our old gens over here, and then we have code cache and this giant one at the bottom. You can do things. You can turn certain ones on and off if you don't want to see them. But it gives you a good view, and as your application is running, as you're performance testing, you can see how these things change. The buffer pools plugin that we suggested is an interesting one because it shows you memory that is outside of the heap space. These buffer pools are, this one on the left here is direct memory, and that is what's been used by the NIO framework in the JVM. And since Tomcat's using NIO in its connector by default in Tomcat 8, and that we suggest the NIO connector a lot, this is kind of important information to see because these buffers will start using memory with that connector. And it's another place where you can kind of lose memory if you're not careful. So it's important to be able to kind of visualize what's going on there and understand if you need to adjust something. I think this last one's probably my favorite because it just gives you such a good overview of everything that's going on in the memory space at the moment. I'm going to crank up the speed a little bit so it's more fun to watch. But basically you can see the different segments of the heap space, our old gen, our Eden space, and our survivors here. You can see that as the application runs, they start to fill up and kind of do their thing. This survivor 1 and survivor 0 here, they kind of flip-flop. So whenever a garbage collection occurs, you'll see them flip. That's all good. Generally what you're looking for is stability in the old generation. So as you watch this graph go over time, you want to see a straight line there. If you see a sawtooth pattern, or if it just kind of keeps going up, that means that things are making it to the old generation and it's starting to fill up, and then you're going to have to worry about a full garbage collection occurring at some point. So as you're tuning JVM options, this is invaluable information to have. So the brand new kind of new hotness that the JVM has is what's called Java Mission Control. And if you have a recent version of Java 7 or Java 8 installed, you can launch this by running JMC from the command line. And it will give you this nice looking tool. It's similar to Visual VM in a lot of aspects, but it does give you some new information as well. On the left here, we can see our processes that are running. This is our Tomcat process, and we're going to connect to that. And it's going to give us some kind of nice visualizations to again, understand what's happening in our JVM. One of the great things about this tool, which isn't quite the same in JVisual VM, is that you can really customize these dashboards to show exactly what you need. So if I'm doing some performance testing, I can click up here and create a new chart. And I'm going to minimize these so you can see better. And right now we have nothing on the chart. But let's say we want to go and grab some information from Tomcat and display it. So I've got a database connection pool that's configured, and we want to look at that and kind of understand what's happening as our application's running. So we're going to come in and we're going to grab some information from that. We're going to look at the number of active connections, the number of idle connections, and the number of the amount of time that the application's waiting to get a connection from that pool. And then, let's see, we'll look at the number of connections that are waiting as well. And if we right-click here and go to Visualize, we can add these to our chart. And we now have that information graphing. And so I really don't know if you're going to be able to see these lines up there because it picks some just awful colors. But when you look at this on your own machine, you'll be able to see them. And what we can see right now is that we have one idle connection that's lingering here, and then we have the rest of our stats, which are just at 0. Now, if I flip over to JMeter and run this little test that I have, it's going to throw a small amount of load at our server. And what we see over here is these graphs start to kind of jump. Turn that off. So we can see that it's jumped up here. We've got 7 active connections. We've got some connections that are waiting. So these are connections that are trying to get a connection from the pool, but they can't because it's too busy. And then we can see that we have 0 idle connections. So if we were load testing and seeing something like this, that's kind of a big tip that, hey, you probably don't have enough connections in your pool. And if we want to test that and see if adding connections helps, we can flip back to our MBean browser here, and we can adjust the maximum. So max total here is that setting. And it's not. Oh, that's right. No, I have to change it on a different one. Sorry, I can change that on this one here. And we'll say flip this up from 3 to 10. And then when we flip back over, we can see that it takes effect immediately. We can see that we're now consuming those extra connections. And better yet, we can see that the number of people that were waiting on connections has dropped down to 0. And that's what you want to see. You don't want to see connections waiting. You don't want to see extra latency for no reason. This other statistic here that I have is nice to look at as well. And this is the average time that a connection is spent waiting. And so, let me pause this. You can see that initially, before we changed that setting, we were wasting almost a second and a quarter just waiting for a connection from our pool. And so those are unhappy users that are unhappy for no reason, because all we had to do was adjust that database configuration. So the last thing I want to show here is JMeter. And if you're not familiar with JMeter, it's a great open source load generation tool. And the view that people typically see is this kind of GUI, but it also has a command line interface. And so if you're running remotely or something like that, you can run from the command line, throw a load at a bunch of servers, and grab all the output, and then load it up into the different visualizations that JMeter has. One of the ones that we're looking at here that's kind of interesting for our purposes is this transaction throughput versus threads. So we can see that initially, we were getting around, we had 7 threads connected, then 8, and then it went up to 10, and it's telling us roughly how many transactions per second were occurring when we had that number of threads running. And that's an interesting point because you can, as your threads increase, you very well can see performance decrease. And in a case like that, what you would actually see is more of kind of a bell curve. So you'd see it go up, you'd see it hit some peak, and then you'd see it drop. And that's going to kind of give you a hint that, at that number of concurrent users, that's where you're going to get your best performance. And if your performance goals, state you need more than that, then you're going to have to start looking at tuning something, to get that up. It's a similar metric to transactions per second, which we can see here. And you can see right here where we changed the number of database connections, how our transactions per second jumped. So these are both useful tools. JMeter out of the box doesn't come with either of these, but there's an excellent open source project that gives you these extra tools. If you just Google for JMeter plugins, I think it's like jmeterplugins.org or something like that. They have a whole group of additional tools that you can get to help make JMeter more functional. Things like enhanced thread groups and additional samplers, and like you're seeing here, these are the listeners that generate the reports. So those are some additional tools that are really helpful as you're load testing and trying to understand what's going on. It's also something too that charts are very nice, when you have to talk to management about performance issues or request more hardware. You have these nice visualizations that you can get from the software to show someone else what's going on.
Thanks, Dan. So we've nearly finished. We're going to leave a bit of time for questions and anecdotes maybe. But our hit list here is of do's and don'ts. Set clear and realistic goals about your performance testing. Really monitor the Tomcat and the JVM process. Understand what the thing is doing. Profile your application. If you're not profiling your application, you really don't understand what's going on in it. And use a load test in an appropriate way. It's been pretty common in my experience to see that customers have been load testing their application to one extent and then putting in production where the load is 5 or 6 times higher. So really, your performance testing has to be realistic. Try to fix the cause of the bottleneck. Don't just address its symptoms. It's often easy to put a quick fix in place, particularly if you're under pressure or the system's fallen over at some point under load. Really try and understand the cause. And don't go any further. When you've hit your goal, stop there. Don't overtune the application. Overtuning the application can increase the fragile behavior of the application as well. It can make it easier to knock the thing down particularly with web applications, you can't always predict in advance what the type of traffic you're going to get is. In fact, I'll tell you a story in a minute about the types of traffic you can get and how application design can impact that. Don't begin optimizing before you measure the performance of the system. Get yourself a good, solid baseline. Make sure you've documented it. Make sure you have it recorded somewhere. If you've got application system monitoring systems that can record this data, it makes for an excellent graph, so you can see where performance goes up or latency goes down after you've completed tuning. There's no silver bullets. There's no quick fix for this. If there was, we'd ship the product like that every time, right? And don't load test on your laptop. Obviously, we've load tested on our laptop here, but you know, do as we say, not do as we do. And don't use unrealistic data volumes. And that means, in both senses, too high or too little. You've got to understand what your user behavior is likely to be. And there's another big danger in performance testing is don't tweak stuff if you don't need to. Performance benefits aren't always intuitive. Something that you think looks like it should go faster, if you change it, may not do that under the wider load that a system produces when it runs together. And don't work on multiple problems at the same time. Knock down one problem at the same time. So before questions, I just thought I'd tell you a little story about a customer I went to when I was consulting for SpringSource, our Tomcat application, and we were trying to understand the performance of our application and some problems that I had with it. And when we first got there, the team was telling us about the behavior of their application and how much load it was under, and they very proudly told us that in their busiest hour of the year that they would do 1 million requests. And being pedantic and a bit OCD about numbers when it comes to performance testing, I had my calculator out, and so 1 million events per hour is about, well, divide that by 60, that's about 15,000 events per minute. That's a request per minute. And then if you divide that by 60 again, you get down to 240 requests per second. I was thinking, well, you know, that's not such a big number. So we asked them how big their application server farm was, and they said, well, we run 4 Tomcats per application server because using 32-bit Java, so they couldn't really use a larger memory space at that time. And they said they have 30 servers. So well, why have you got 30 servers? 30 servers are 120 Tomcats. What's the spec of your servers? And they said, well, it's an 8-core machine. So each Tomcat has 2 cores available to it, 240 requests per second. So you basically got 1 request per core per second. How do you feel your data center is performing? They said it's performing really well. That's like, because even in the busiest hour of your year, it's doing no work. But when we dug into why the application infrastructure looked like this, we found that earlier in the application lifecycle, the engineering team they were using at the time, outsourced, so the customer could blame them, it's a retail website, and the customers started using the search functionality more than any other piece of functionality. And the application team were using Hibernate, and the search results were coming back, and it was a very expensive query, and Hibernate was basically pulling all of the objects in the database into the application. And they found that when the users hit the search, got the search results, they'd click on the item in the search results that they were interested in, and then click back afterwards. And this was causing the whole search execution to completely rerun. So the smart idea that they had was they would stick the search result set objects into the user session, so that when the user session came back, they would check to see if the query matched the user session. If it did, they would just load that page up. And of course, this worked beautifully. The search query was fast, the user load on the database went down, and of course, memory utilization went up. And they found that, in fact, it only took 5 users concurrently to execute a search on a given Tomcat to cause the Tomcat to OOM. Instant built-in denial of service attack. And their solution was to scale out the data center, because they didn't understand the consequence of this behavior in the application. They didn't profile it, they didn't measure the memory, and they weren't able to understand what the application was doing. And the development team was detached from the operations team, so there wasn't a good communication channel. So what Dan was saying about sharing profiler and monitoring information back to the development team is critical to the success of your application. So they scaled this application system up, and eventually someone noticed why this was happening and paginated the results and cached data lower down in a second tier. And of course the application started behaving itself again and improved, but they still had this massively overspecified data center, which naturally the engineering team were really proud of. And the only guy in the room when we figured this out who was happy was the VP of engineering, because he realized he was going to cut his data center costs in way under half. So I've got more of those. See me later. If you have any questions, now is a good time. I will take yours first, sir. Repeat the question.
Could you repeat the question?
Sorry, yes. So the question was, would I recommend the upgrade from Tomcat 7 to Tomcat 8? So Tomcat 8 was declared stable at, I think, 809. Was it 809? So 8010 or 809. So it's only 2 releases on from that. Tomcat, being an open source project, relies on users to get good feedback about the stability of the product. Version 8's been out for a year, so it's had some of the wrinkles ironed out of it. And so I would say for a small to medium sized website, it's worth going to Tomcat 8. If you have a desire to see the features in the servlet specification that have come through, maybe you need WebSocket support or something like that. That would be a big motivation for moving forwards. I would tend to recommend that you evaluate every new release of one of these products as soon as you possibly can, so that you understand how it changes the behavior in your application. And if you have new features available in the container, it takes some time for your application team to get around to doing that. There's most of the performance, as we said, is in choosing the connector in terms of Tomcat and making sure your memory assignment is good, which is nothing to do with Tomcat, it's to do with you. So the connectors fundamentally haven't changed. The only thing that's new in 8 is the Neo 2, and that we wouldn't say that's stable yet. So yeah, why not? Would be my answer. Test it first. You know what we said about testing.
Yeah, the only thing I would add to that is just also realize that there's going to be some configuration change from 7 to 8. So plan for some time to kind of go through and evaluate your configurations and see what's going to what you're going to have to migrate as you do that. The sooner you start looking at, the better, because then when you want to go and migrate your production instances, then you're going to be on top of that and ready to go.
Next question.
Yeah, we've been using blocking IO forever. I'm very familiar with thread for request model. I'm also very familiar with fully asynchronous, so XD or string node model. But I don't understand the NIO model and how it relates to what you end up doing on the interactive application server, like the thread for request. That interchange point is confusing to me. Can you kind of elaborate on that a little bit?
Okay, so the question is about the difference between blocking IO, BO, and Neo as far as Tomcat connectors are concerned.
Well, it's really about the interrelation between NIO, which is asynchronous, and your actual application, which is still relatively synchronous unless you're using like continuations or
Okay. Yeah, so the question is about the difference between BO, Neo, and how that relates to your application. And then the synchronous or asynchronous state of your application. So asynchronous features didn't really appear in the Servlet API until more recently. Neo's been around for longer, so let's clear up what that is. Non-blocking I/O in the Tomcat connector, even though the handling of the request and response is blocking, just means that we take advantage of features effectively in the operating system that allow us to trigger an event when a write or a read is occurring on the channel that's conducting the operation, which means we can more efficiently assign the thread pools to where the work is going. So we can have a lot more connections open. Typically with a Neo connector, you can see 10,000 connections open, and that's decoupled from the thread pool that's doing the work. Obviously you have a pool of workers that still have to service those, but an HTTP request does a piece of work that comes in which is short, and your application does a ton of work thinking about doing stuff before it actually sends some stuff back at the other end. And so the connector that's handling all of that work is really these two pieces and nothing to do with this piece. So you can effectively multiplex the operations as far as the input and output is going on the application. And you can't do that with blocking I/O behavior. Now, in the middle bit where your application is doing the work, if you're using asynchronous features of the container or sub beneath that, you're still, if you're doing operations that hand off to some other asynchronous service and you do a full wait, you're still blocking here on the thread. The asynchronous features that have been in recently allow you to defer some of that work, so you do get the ability to have an extra layer of insulation between that outer layer that's doing Neo and this inner layer. But really, the boundary between where your application is doing work and where it hits the edges, and the asynchronous nature of that is only ever about what your application is really doing. And I'm not sure that's entirely the answer or clarity that you were looking for, but I hope it helped some. Hello, sir. Yeah.
Yeah, in the beginning, you discussed that connectors are tunable. Can you elaborate on which connectors you had actually tuned, modify parameters from the default values, and like a use case that forced you to do so?
Yeah, okay. So the question was, which connectors have I or have we tuned, and what kind of reasoning do we have, I guess, is a summary. Okay, so blocking, I almost always enabled the Neo connector. Most of the applications we saw, for the reason I would go to a customer was because of the performance problem. The reason that Dan gets shouted at on the support side is because the customer has some kind of problem, performance or otherwise. So the Neo connector has actually been pretty stable for a long time, and it is almost always a benefit, particularly under applications that are seeing large number of connections for the reason we just explained, which is it can handle more connections, it can keep more connections open concurrently, which means you can service more clients. Otherwise, on the blocking I/O connector, you end up with a backlog of clients who are waiting and they're unacknowledged in effect, so they can time out. And there are proxies between you and them on the internet, out there in the wild, and there is no guarantee that what they're seeing is the reality of what the connection is. There's no kind of guarantee that there's a short point-to-point traffic there, so connection there. So that timeout is a really big deal initially particularly when you come under load on the system. So Neo helps you a lot there because it can establish that connection and give the client something to get through those first phases of the connection lifecycle. Most people will trade more connections for a little bit more latency or that kind of very small extra cost you pay. And so typically it would be switching to Neo, picking an appropriate number of worker threads in the connector thread pool. I almost always ended up enabling the executor, which is a component which sits behind the connectors. So you can either have a per connector thread pool or a common thread pool, which is used across multiple connectors. This is particularly useful if you're running SSL and HTTP, both of those connectors, because when you switch from one to the other, it means that it's a common thread pool. It's unusual, for example, for you to say, or it would be a badly designed application where you were in SSL in one space and not encrypted in the other. And then you would have two separate thread pools, one which was being used only for the switch over to SSL, and one which is dormant. And that one would be dormant for the time that it's not handling work. So that common thread pool is a useful thing to maintain and manage resources. Infrequently, we would need to change connection count limits. Sometimes that you need to put a hard limit on those for security reasons. You don't want to open too many connections per server. But other than that, the vast majority of cases are really just about picking the right number of connectors for the connections and threads for the workload that you're expecting. And then we would move elsewhere into the application. As we're kind of asserting in excess of 90-something% of the tuning that's available to you, the trade-offs you'll get will be in your application.
Yeah, the only thing I would add to that is that often on the connectors you'll also tune some timeout settings. There's a connection timeout, which is essentially the amount of time that the client has to connect and present the request, to say what they're looking for. So I think by default it's somewhere around 20 or 30 seconds, which is very high. And so oftentimes, the first thing I'll do is lower that. I think maybe 5 seconds is pretty acceptable in a lot of circumstances. The only time you have to have a longer connection timeout is if you've got like really slow clients. So if you're doing something with a slow mobile network where you've got a lot of latency, or you're supporting dial-up modem users for some reason, you might have to have a higher connection timeout. Besides that, there's also, because connection timeout, it kind of trickles into some other settings, which are, take their defaults from connection timeout. So it can also affect things like large file uploads. So if you have a content management system where you're uploading giant images or music or movies, you may need to adjust a separate timeout for that. There's, I believe, I don't remember the exact name, but it's a connection upload timeout, something like that. And you can set that separately. So if you have large file uploads, that's one that you'll probably want to set as well. But other than that, it's not a whole lot. The test that I showed some information from, we're all using out-of-the-box configurations, other than the fact that I had to create a key store for SSL. That's really the only thing that we adjusted there.
Your load generators were consistent 50 clients on all bases?
Yeah, in the test, all of them except one. The only one where I increased the load was with the large file, and the reason for that was because at 50 connections to the Tomcat server with the large file, it wasn't even a blip on the CPU. Because Tomcat's very efficient with large files. It has support for send file. And so essentially it's just taking the request and offloading it to the kernel and saying, give them this file. And so it really didn't do anything to the CPU. So in those cases, I actually pushed it up to 500 clients. And at that point, I was seeing somewhere around like 70 to 80% CPU usage. And I actually maxed out the gigabit network at that point. So you can kind of get a feel for, how the efficiencies Tomcat can offer. I know there has been in the past kind of this myth that, Tomcat can't do static files. It's not efficient enough. That you have to put a web server in front of it or something like that to handle your static files. That's absolutely not true anymore. Especially if you're using the APR connector, it can be incredibly efficient, serving up your static resources as well.
So, in case of OAuth2-based applications where it's pretty much SSL all the way, so APR connector would be the one to go for, that would be
I would suggest at least starting with the NIO connector. It does have some benefits with SSL, because it's non-blocking, so it can help a little bit there. You're not going to see the giant performance difference like we saw with APR. If your workload is relatively low, you might be fine with the NIO connector. If you're servicing a lot of clients, it's probably worth your time to go to APR. The bonus there that you get is pretty substantial. So that extra time that it takes to to go to the machine, compile the native code, and configure it, is kind of worth it.
Unrelated, but another question that I had was, we talked about keeping the test environment as close to production as possible. In terms of generating the load, you want similar, the characteristics of the load should be similar to what you expect in production as well.
Yeah, and this is where, I think way back at the beginning when Stuart asked, how many people know how much load, their app takes in production. That's why it's important to know that, because when you go to test in your testing environment, you want to make sure you're generating an adequate or an appropriate amount of load. You don't want to be generating 10 times the load and never have a circumstance, even in peak, times where you would hit that. So you kind of have to first know, what your expected load is going to be, and then try to figure out how you're going to generate that load. And when you're testing an application, it's a little trickier too, because in our scenarios, we were just downloading a single file. So it's very easy to generate a script that does that. But if you're testing workflows, you know, someone comes to the site, like Stuart was saying, clicks on a search, then picks an option, goes back, you know, pulls the search up again. Those are a little more tricky to, you know, kind of get JMeter or another program to copy those flows. And so you end up with a lot more complicated load scripts. Sometimes you need more, you know, that can create a need for more client machines, you know, to do your load testing. But yeah, you want to try to be as accurate as possible just so that you understand. You know, it's not sufficient to say, okay, well, my actual load is 1,000, you know, requests per second. I'm going to do 100 and then just multiply by 10 and assume I can do that. You know, that doesn't hold up.
Okay. One last question? Anyone? What's the most common stupid thing I've ever seen customers do? We see a lot of the same questions over and over again on the Tomcat mailing, on the users mailing list, and customers tend to do the same thing. Same things, plural. Now pick one.
Yeah, I'm trying to think of a good example.
Opening emails that start with, I'd like to tune Tomcat because I've just deployed my application, normally make me roll my eyes. Because, you know, we're saying, no, there's so much of the benefits in your own application that that's always an excellent way to look at the situation. It's not true.
Yeah, I think it's just kind of the, you know, looking at the optimization in the wrong frame of mind, you know, thinking that, you know, Tomcat is just going to magically solve the problem with some setting that they don't know about, you know, and that's just not the case. You know, I'd say some of the issues that I've encountered that have been particularly interesting are, you know, cases where people have, you know, gone ahead and copied a bunch of settings, you know, from, you know, some blog post or Stack Overflow, and just, and you can just tell because, you know, you look at you know, the JVM options and there's just 50 of them, and, you know, the first question is generally, did you test all those? Do you know how those are impacting, you know, your application? And I would say in every case I've encountered, the answer is no. So, you know, those are kind of things that you can do to shoot yourself in the foot. And, you know, if you stick with the basics and kind of go slow, you can, you know, do a lot better.
I'll tell you something dumb I did. That's probably good. I encouraged a customer to upgrade a Tomcat, and I hadn't checked something, and we discovered a bug in production in Tomcat that applied a connection limit to the number of inbound connections that never went down. It went up, but it never went down. So we took out a global payment processing system in production for hours. Yeah. Every time it restarted, it looked like it came back up perfectly, and of course it just took a little while for it to go back down again. Yeah, that was unfortunate. We found a bug in Tomcat, fixed it though. Okay, thank you.
Thank you.